Generally speaking, Kubernetes should be the last thing you reach for rather than the first. It is scary.
When you're building something new, a new bit of software, a SaaS or whatever, you don't need microservices and you don't need Kubernetes. Microservices are really complicated and Kubernetes is really complicated.
Let's keep things simple, because most of the time you don't really need Kubernetes.
Is that Kubernetes is designed to manage complex multi-container applications across multiple machines. And if you are just starting out or working on smaller projects, you don't need that level of complexity, especially small startups.
So I built my startup SaaS on Kubernetes and I've been loving it. It's easy to deploy. My services are templatized for easy deployment. I can deploy the whole stack locally with no dependencies on any external services, and it's easy to reason about the whole system. I've been working on this app for about the last year in my spare time. The goal is to help streamline common tasks that teachers do that are enabled by advances in machine learning and LLMs. A few use cases that we're focusing on initially are the rubric generation and student Q&A. For example, a teacher could publish a Q&A chatbot for their students using all their class documents. Then, using RAG and citation generation, we can provide high-quality responses that are grounded by the teacher's class materials. To support this, the app needs to handle long-running ML tasks, document uploads, and streaming. Before we get too far, I should also mention that I've never built a SaaS app before. In my day job, I'm a machine learning engineer and data engineer, and some of my work involves setting up Kubernetes clusters and building and deploying various tooling on them. So, as you might have guessed, this architecture is more complicated than it needs to be, but so far it hasn't felt clunky or slowed me down. I've probably spent the most time on the front end and JavaScript just because that's the part I'm least familiar with. So with that in mind, let's check out my SaaS app's architecture and see how it's enabled by Kubernetes. I guess I would call this architecture a modular monolith. Everything ties into a single database, but I have a queue that allows for the backend to be deployed independently from my async processing modules. I chose this setup since I knew I would have long-running jobs that would be somewhat complex. With the processing modules, I separated out a lot of that complexity from the backend, and I think it's made it a lot easier to test and debug. A key part of this architecture was to only use open source tools. This made the project easy for other people to deploy and run on their own hardware if we open source it in the future. The one exception to this is we're using OpenAI, which is currently the only LLM that we've been testing. Most people can't reasonably host large enough LLMs on their own hardware to produce quality responses, so it does require OpenAI key to run properly, but that's the only service we depend on. Another notable technology decision was using HTMX tailend and vanilla JavaScript on the front end. I was trying to keep things in the front end simple since I have the least experience building front ends, and I had some trouble organizing the HTMX and JavaScript at first, but I think I found a decent way to organize my files, or at least gotten used to how it's laid out. And I haven't done anything with TypeScript since I've still just been learning JavaScript. Over time, I've been weaning myself off of LLMs as well for generating the JavaScript as I've gotten more used to the syntax and more familiar with the DOM methods. Next, Postgres was the obvious choice for the database, plus it has a PG vector extension to support vector storage and querying without needing another service. For my schemas, I've been trying to balance supporting analytical queries later on without a bunch of data manipulation, so I've been doing some denormalization of the data in some cases and breaking third normal form. We'll see if I end up regretting this later. The backend was also an easy choice. I'm very familiar with Python and FastAPI, which will keep things simple. FastAPI has good async support. It doesn't have strong opinions on how your app needs to be set up, unlike some other Python frameworks. Since I'll be dealing with a lot of files uploaded by users, I chose to go with a dedicated file storage using Mini.io. This frees up my database, which doesn't have to handle large files. And Mini.io has a lot of other good features for file handling. Auth handling is another area that I'm not as familiar with, so I wanted to choose a robust open source solution instead of rolling my own. Keycloak provides a ton of features out of the box and follows a secure by default principle. I think if anything, it's probably a little bit overkill for this project, but very robust. For my queue, I've been wanting to play around with RabbitMQ, so that's what I went with. And so far I'm just using a simple queue, have no regrets. This app is still a work in progress, so there's some services I don't have set up yet. Argo CD isn't set up, and self-hosting LLMs isn't practical yet at my current scale. Currently, I could swap out OpenAI with Ollama, but if I had to use cloud GPUs, my costs would skyrocket. And then I also don't have some monitoring services like Prometheus and Grafana set up. Finally, Kubernetes is what makes all this work. I have a Helm chart that's the deployment template for all these services, which lets me spin up everything with just a few CLI commands. It's fantastic. The Helm chart also makes it easy to test across multiple environments. I can provide my values.yaml file with all my key parameters and easily switch between an unsecure local setup and my production deployment with TLS and other security features enabled. With GitHub Actions, I'm automatically building all my service images, and then I push them to main branch in my repo, and I can specify which image versions should be used automatically when I update my Helm chart. And yeah, going with Kubernetes has a lot of benefits beyond what I just outlined, but this architecture definitely has impact on infrastructure costs. Right now I'm deploying all this on GKE Autopilot, which charges based on the resources reserved for each pod. Since I have about 6 main services, I end up overpaying quite a bit compared to the resources that are actually being used, since there is a minimum resource request that dictates these costs. So with this setup, I'm paying about $300 per month for my resources for my 0 users. This is definitely a lot more if I just used a single container on something like AWS Containers, which would have cost around like $10 per month. But I would have had to completely re-architect everything if I ever got enough users to make the app viable. In the big picture, if $300 per month makes or breaks this startup, it probably wasn't going to work anyway. And also for early stage startups, we can get around $2,000 of free cloud credits on most platforms. So that $300 per month could last, half a year of free credits. Overall, if I wasn't familiar with Kubernetes, I probably wouldn't have gone with this architecture, but I've learned a ton deploying on Kubernetes and going through the process of idea to production. For me, it's been worth it since it's had a direct impact on the work I do in my day-to-day job. I'm currently working at a Fortune 500 healthcare insurance company and doing some Kubernetes related work for them that other data engineers would have no idea how to do. And I can kind of understand their architecture at a deeper level by going through this process of setting it all up myself. If you're interested in a deeper dive of the code, let me know in the comments. You can find the latest updates at teacherspet.tech to see kind of where the startup app is at. And thanks for watching.